my name is ATM Teaches Math, and today we're going to look about a new subject of a topic. And I'm now talking in English because I really need an English video. It's been about 2 or 3 months last time posting English video for telescoping for math. So now I'm gonna start a series of classes for a new subject called Combinatorics. Firstly, I want to thank you guys for making it 10k views for me and Yurisma TV. And now I'm going to start. This is me, by the way. This is me, and I'm a combinatorics teacher from South Korea. And now let's start for combinatorics. But before I start, in this page, I'm going to talk about the history of combinatorics. So let's get into it. So what I'm going to say is not that really hard thing. It's just a history. So you just hear it and you'll understand. So a combinatorics. This is only a 300-year-old theory. And you might think, that's pretty old, but let's think, when did we first use math? Let's think, when did we first use 1, 2, and 3? This has been about 4,000 years ago. And this is when number theory started. Number theory started by 1, 2, and 3. And something like 2 is 1 times 2. 4 is 2 by 2. And something like this, number theory started. And then a lot of years later, about 3,000 or 3,500 years ago, we have attended and achieved to geometry, and algebra. So, what is geometry and algebra? Geometry, my pronunciation is weird because I'm South Korean. I say geometry, not like geometry. So I should put focus on geometry. So I should put focus on the geometry. Anyways, in geometry and algebra, we use something called x. X is a number we do not know. For example, when 2x equals 6, x equals 3. And let's say we have a square that x by x, and the area is 14. This is geometry and algebra at the same time. What is x? Square root of 14. That's easy, right? Pretty easy, huh? But now, that's very easy. That's just literally a way to calculate things. But this 300-year-old theory of combinatorics is abnormal. We're talking about things just proving it in mathematical ways. So let's get started by proving one simple lemma. As lemma, I mean a little theory in United States English. So let's start with some simple combinatorics question, for example. But before that, I should tell you my today's achievement point, which is PHP. Do you know what it means? It means Pigeon House Principle. Well, I'm erasing everything because I'm not good at writing on my tablet. So, Pigeon House Principle is what PHP means. And I wrote those 9s because in South Korean 9 is something like goo 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 in Pigeon language. So this is a cute way of saying in Korean for pigeons sound. So let's get started. What is PHP, by the way? That's what I'm gonna talk about. Pigeon House Principle. So it's a very fun thing. So let's say we have these N companies. And in these N companies lives N chairmen. For example, we have Apple. Oh my god, I did not cut that apple. We have Apple, and inside there lives Tim Cook. And then we have Tesla. I'm sorry, I'm not good at drawing logos, but we have Tesla, and let's say inside lives Elon Musk. And something like this It goes on and on and on. And then at the last, let's just say in Trump Hotel lives Donald Trump. DJ Trump. So anyways, we have N companies and N chairmen. So per one company, like a building, one chairman lives. But we took an overview, and suddenly, just suddenly, let's just say chairmen can only live in companies, even though they are not. It's not their companies, but that will be very bad because they have a lot of money, they make a lot of money, and they need to live in companies because if they live in other companies, that means that's a war. They need to contract it. So, anyways, let's say one company just died. So, for example, a company named, I don't know, let's say, I don't know, let's just get random, like ATM company got exploded and they are on bankrupt. And this chairman is called ATM Math. And this guy wants to live in other companies because he's a very small company. He uses, I don't know, 1 square feet room for his house. So he wants to live in Apple, Tesla, or Trump Hotel or anything. Now, if ATM Math can only live in these other companies, then we can show that between these other three companies, we have a place that ATM Math and one other chairman lives. So what I'm going to show you is that if we have n minus 1 companies and n chairmen, then we could show that at least one company, at least there exists one company that has 2 people, at least 2 people. So this is Pegion's theorem, a principle. But if we go a little bit deeper and organize it in a better way, we should go by n companies and n plus 1 chairmen. A n plus b. But b is over 0 and smaller than a. N. Then, at least one companies, in at least one company that, at least we have one company that has a plus 1 people. That's obvious. So now I'm going to go to another problem. It's South Korean. Well, it was South Korean in my South Korean video called ATM Combinatorics. Pegion's principle in South Korean. I have an English dub version, but YouTube wouldn't let me upload it because Mr. Beast has all those dub version because he's a 300 million YouTuber, and I'm just a 300 YouTuber. They won't allow it. They are saying that I need to have something, a legitimate something, but I don't know. I don't like it, so I'm just gonna forget all South Koreans and get back to what I was doing, English math. So, in English math, I will read you the question in English. So, we have a 3x7 rectangle. And now I color in red or yellow, but I'm sorry I did not prepare those colors. Red or yellow. Ketchup or mustard. Now, let's say I did anything possible to color red. Well, like that. I think that's okay. Okay, and then I just do yellow. What the problem wants to show you is that if we color it like this, like every corner and sides of it, and same for the red, we have a rectangle that four corner is the same color. So if we go like this, now do you see a rectangle that has the same four corners of a color? Let's see. 1, 2, 3, 4. They're all yellow. And it's apparently a square. In any case, that becomes, there's at least one place that the square is the same corner of yellow or red. And why? I don't know why. We're going to prove it in a very mathematical way of combinatorics. So now let's go deep in. So we have 3 by 7. And we're going to put it red or yellow. And let's see of these 7 lines. Here, 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 and here. And for every these 3, we have only 8 cases of putting red or yellow. Red, 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 yellow, red, 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 yellow, red, yellow, yellow, and yellow, 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 red, yellow, red, yellow, yellow, red, red. These 8 cases, and now I'm going to pick 2 cases that are very special. We need it for today. Red, 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 and yellow, yellow, yellow. Besides these 2, they're not that important, but now let's start. Let's say we have we have a red, 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 or a red, yellow, 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 or both. Let's say if we have both of these, then let's try to make, our goal is to make a rectangle that the corner is every different. Now, let's say we have both of red, 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 and yellow, yellow, yellow. If we have more than 2 reds, or the same, or more than one, just bigger than 1 red, or bigger than 1 yellow, there becomes 2 yellows that becomes like this. So that's not possible. And same with red. If we plus it, it becomes 2, and that's smaller than 3. Doesn't make sense. So let's say we just have red, red, red. And in this case, we should pick all the 6 by these, because this is impossible. But we know that if the same 2 goes in, we have the same 2. So red, yellow, red, red, yellow, red, 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 red becomes a rectangle. So we're picking these 6. But as I said, if we have more than 2 reds, we're done. So this is also impossible, same for yellow, yellow, yellow. So if we do not have red, 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 and do not have yellow, 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 we have these 6 cases, and by Pegion's principle, we're going to show you the ceiling function of 6 under 7, which becomes 2. That means if we pick between the 6 to check out 7, we have at least one case that has happened 2 times, which becomes the same corner. Next question. 3 times 4 rectangle. There is apparently a 3 times 4 rectangle. And like this, probably. I guess this is okay. Okay, 3 times 4, we have 6 points inside. And then we make it root 5. We have 6 points inside, and we're going to show that between these distances of 6 points, we have a distance that doesn't go over root 5, smaller than root 5, or maybe the same. It's not bigger than root 5. It's not greater. So how do we solve it? Most of you just pause the video and think. Most of you will say how to divide the shape. Oh, that's too easy, bro. How that's not a question for Aiden teaches math. He's very good at it. But you're thinking like 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1. Because root 5, root 5, root 5, root 5, root 5, root 5, and 6. But wrong. If you need to use Pegion's principle, we should have more than it. So that means we should have divided to 5 shades. How do we do it? That's our main question. Pause the video if you like to give it a try. I'm sorry, I was following mind your decisions. Anyway, we're going to make it into a house like this. And then we have 1, 2, 3, 4, 5. And a period. Inside at least one shape, we have 2 points because of by PHP. Ceiling 5 under 6, 1.2 is 2. So we have at least one shape that has 2 points inside. For example, let's say it's this. So inside this, let's pick 2 points. And the maximum is literally just this. Here. Cannot go over. Root 5 is the best. So, what we showed is that root 5, it means that it doesn't go over root 5. It's under or same. It's not greater than root 5. I just showed. It might be same. The shout is not greater. Yes. So that was my PHP. Maybe I talked about a little unnecessary things, but I hope you like it. I'm just making it a little fun for you. And then teaches Combinatorics out, and I'll see you with the next video with invariance theorem. And I'm not sure when, but keep tuned, and I hope YouTube lets me make multi-languages audio track. Anyways, Aiden teaches math out. See you on my next video of invariance theorem. Thank you very much for watching my video.